Take a slow, deep breath and allow your body to relax. Settle into a comfortable position and let your mind become calm as we begin our journey into the quiet depths of space. Tonight, we travel far beyond our world, far beyond our sun, and beyond the familiar stars of our own galaxy. We are heading toward a distant neighbor in the universe, a place that has fascinated astronomers for generations. This place is called Andromeda. Andromeda is a massive galaxy, similar in shape to our own Milky Way. It is made up of billions of stars, along with clouds of gas, dust, and countless unseen worlds. Even though it is one of the closest large galaxies to us, it is still incredibly far away. The distance is so great that the light we see from Andromeda today began its journey millions of years ago. When we look at Andromeda from Earth, we are not seeing it as it is right now. We are seeing it as it was in the distant past. The light traveling from that galaxy has spent millions of years crossing the emptiness of space just to reach us. In a way, every time astronomers observe Andromeda, they are looking back in time. This idea is one of the most fascinating parts of astronomy. Space is not only about distance. It is also about time. The farther away something is, the older the light we see from it. When scientists study Andromeda, they are watching a story that began long before human history as we know it. Now imagine moving slowly closer to this galaxy. Not quickly, but gently, as if drifting through calm and endless space. As you approach, you begin to see its true shape. Andromeda is a spiral galaxy, with wide arms of stars curving around its center. These arms stretch across space in a slow and steady rotation. Inside this galaxy are billions of stars, each one moving along its path. Nothing here is rushed. The entire galaxy turns slowly, and one full rotation can take hundreds of millions of years. Everything happens at a peaceful and steady pace. Star clusters can be found throughout Andromeda. These are groups of stars that travel together through space. Some clusters are young and bright, filled with new stars that have recently formed. Others are older, their stars glowing more softly after billions of years of life. Between the stars, there means open space, calm and silent. There is no sound in space, only motion. The stars continue their slow journey, held in place by gravity, moving together as part of something much larger than themselves. As you imagine drifting through Andromeda, picture the gentle glow of distant stars all around you. Some shine brightly, while others appear faint and soft. Each one has its own story, its own beginning, and its own long life ahead. Take a slow breath in, and then breathe out slowly. Let your breathing become steady and relaxed. Imagine that your breath matches the calm movement of the galaxy. Slow and peaceful, with nothing to hurry and nothing to worry about. Before we continue further into the galaxy, I'd like to invite you to join our peaceful journey. If you're enjoying this slow drift through the stars, please consider subscribing to the channel so you can continue exploring space with us. If this experience brings you calm and wonder, a like or a share will help others find this quiet journey as well. And now, let's continue our journey deeper into the life of a star. Astronomers spend years studying galaxies like Andromeda. They observe the movement of stars, the patterns of light, and the changes that happen over time. By watching carefully, they learn how galaxies grow, how stars are born, and how they live out their long lives. Andromeda is especially important because it is close enough for us to study in detail, yet far enough to remind us just how vast the universe really is. It is like a quiet neighbor across a great distance, slowly moving through space. When scientists look at this galaxy, they see more than just light. They see history. They see motion. They see the slow passage of time written across the sky. And sometimes, during these careful observations, small changes are noticed. A star that once shone steadily might begin to fade. Its light becomes weaker, slowly and quietly. There is no loud event, no sudden explosion. Just a gentle change that takes place over time. For now, Andromeda remains calm and steady. Its stars continue to move in their slow rotation. Its light continues its long journey across space. It remains a peaceful and distant presence in the universe. Take another slow breath in, and then let it out gently. Allow your mind to stay relaxed as we continue drifting through this quiet galaxy, surrounded by countless stars, all moving slowly together in the silence of space. Now that we have slowly drifted through the quiet beauty of the Andromeda galaxy, we begin to focus on something more personal and more meaningful within it, the life of a single star. Every star has a story. A beginning, a long period of life, and eventually an ending. But unlike the short lives we are familiar with on Earth, the life of a star unfolds slowly over millions or even billions of years. It all begins in darkness. Deep inside a galaxy like Andromeda, there are enormous clouds of gas and dust. These clouds are cold, wide, and silent. For a very long time, they simply float through space, with no light and no movement that can be easily noticed. But slowly, gravity begins to do its work. Over time, parts of these clouds begin to pull together. Gas and dust gather into denser and denser regions. The more material that collects in one place, the stronger the pull of gravity becomes. This process continues for thousands, sometimes millions of years. As the cloud slowly collapses inward, the center begins to grow hotter and hotter. The pressure increases. The temperature rises. Everything moves slowly, gently, and steadily toward a moment of change. And then, at the heart of that cloud, something new is born. A star begins to form. At first, it is only a growing sphere of hot gas. But as the temperature in its center rises high enough, a powerful process begins. This process is called nuclear fusion. Inside the core of the young star, tiny particles begin to combine. As they join together, they release energy. This energy pushes outward, creating light and heat. The star begins to glow. For the first time, a new light appears in the darkness. What was once just a quiet cloud of gas has now become a shining star. This moment is not sudden or violent. It is slow and steady. The star gently grows brighter as it settles into its new life. And then, for a very long time, it remains stable. A star spends most of its life in balance. Gravity is always pulling inward, trying to collapse the star. At the same time, the energy from nuclear fusion pushes outward, trying to expand it. These two forces work against each other, creating a steady and peaceful balance. As long as this balance continues, the star remains strong and bright. For millions or even billions of years, the star shines steadily. It gives off light and warmth into the surrounding space. From a distance, it appears calm and constant, like a small, steady flame in the darkness. In galaxies like Andromeda, there are billions of these stars. Each one quietly living out its long life. Each one glowing in its own place, following its own path. Some stars are small and gentle, shining softly for an incredibly long time. Others are larger and brighter, using their energy more quickly. But no matter their size, they all share the same quiet purpose: to shine. These stars become gentle beacons in the darkness of space. They guide the structure of galaxies. They light up the endless night. And they do this for longer than we can easily imagine. When we look up at the night sky from Earth, the stars we see can feel familiar. They are always there, appearing night after night. They feel constant and dependable. For generations, people have looked at the stars for comfort, for direction, and for meaning. Long before modern science, people noticed their steady presence. The stars became symbols of patience, strength, and endurance. They shine through the passing of time, through changes on Earth, through the rise and fall of civilizations. Even though the stars are incredibly far away, they can feel close to us. Like quiet companions watching from above. Always present. Always steady. Each star you see in the sky is living a long and peaceful life, holding itself together through a delicate balance. Deep inside, energy is being created every second, allowing it to continue shining. And yet, from the outside, everything appears calm and still. In the Andromeda galaxy, just like in our own, countless stars are in this stage of life right now. Born from clouds of gas, they now shine quietly in the darkness, holding their shape and their light through the steady balance of gravity and pressure. They do not rush. They do not struggle. They simply exist, glowing gently for ages beyond human understanding. And as we continue our journey through this distant galaxy, we remember that every star we see has its own beginning. Its own life. Its own story unfolding slowly across time. Some of them will shine for billions of years without change. Others will slowly grow older and begin to transform. But for most of their existence, stars live in peace, shining steadily as silent witnesses to the universe around them. As we continue our quiet journey through the Andromeda galaxy, we begin to move towards something less visible, yet deeply important. Among the countless shining stars and drifting clusters, there are regions of space where light does not escape. These regions are known as black holes. Black holes are often described in dramatic ways, but in reality, they are not cosmic monsters. They are not roaming through space with intention or hunger. A black hole is simply gravity taken to its most extreme form. It is a place where matter has become so concentrated that its pull is stronger than anything around it. To understand a black hole, we return to the life of a very massive star. Most stars live long and stable lives, balancing gravity and outward pressure for millions or billions of years. But the most massive stars burn through their energy much more quickly. They shine brighter, live faster, and eventually reach a point where the balance inside them can no longer be maintained. When a massive star runs out of fuel in its core, the outward pressure that once held it up begins to fade. Gravity, which has always been pulling inward, suddenly takes control. Without enough energy pushing outward, the star can no longer support its own weight. The core collapses inward under its own gravity. In some cases, this collapse can produce a bright explosion known as a supernova. But if the star is massive enough, even that explosive event is not enough to stop the inward pull. The remaining core continues collapsing, becoming smaller and denser. Gravity grows stronger and stronger as the core compresses. Matter is squeezed into an incredibly small space. The pull becomes so intense that nothing, not even light, can escape once it gets too close. At that point, a black hole has formed. It does not shine. It does not glow. It does not send out light like a star. Instead, it sits quietly, defined only by its gravity. It can only be detected by how it influences the space and objects around it. In a galaxy like Andromeda, black holes are not unusual. In fact, most large galaxies, including our own Milky Way, are believed to have enormous black holes at their centers. These central black holes can contain millions or even billions of times the mass of our Sun. Yet even these giants remain silent. There is no sound in space. No echo. No roar. Even the most powerful events unfold in complete silence. When matter falls toward a black hole, it may heat up and emit light before crossing the boundary, but once it passes beyond that point, it disappears from view. There is no dramatic noise. No final signal. Only motion. And then absence. The boundary around a black hole, often called the event horizon, marks the point beyond which nothing can return. If light crosses that boundary, it cannot escape. From the outside, it appears as though the object has simply faded away. In many cases, this process is not sudden. It can be gradual. Matter may spiral inward over time, slowly drawn closer by gravity. As it moves inward, it may glow briefly, but eventually it crosses into darkness. And then it is gone. Now imagine drifting through a quiet region of space near one of these unseen objects. There are still distant stars shining softly in the background. There is still the slow rotation of the galaxy. But ahead, there is a region where light bends and dims. The darkness here is not empty. It is shaped by gravity. It has presence, even though it cannot be seen directly. Take a slow breath in, and let it out gently. Picture the calm of deep space. Wide and open. No sound. No wind. No movement that you can feel. Only the silent drift of matter under the influence of gravity. Black holes do not chase. They do not search. They simply exist, and their gravity does the rest. Objects that wander too close may find themselves caught in that pull, drawn inward step by step. From far away, everything appears calm. A star may orbit peacefully for millions of years. But if its path changes, or if it drifts too near, gravity will slowly begin to take hold. There is no shouting in the universe. No alarm. Only the steady laws of physics unfolding as they always have. The hidden darkness within galaxies like Andromeda is part of the same cosmic balance as the shining stars. Light and darkness exist together. Gravity shapes both creation and collapse. As we continue our journey, we move deeper into this quiet understanding. Space is not only filled with glowing suns. It also holds regions where light cannot remain. And in that silence, events can occur without noise, without explosion, without warning. Only motion. And then disappearance. As astronomers continued observing the Andromeda galaxy, carefully tracking its countless stars, something unusual began to appear in their data. Among the steady lights that had shone consistently for years, one particular star began to change. At first, the change was subtle. The star's brightness appeared slightly weaker than before. This was not uncommon in astronomy. Some stars naturally vary in brightness over time. Others are briefly obscured by dust or affected by surrounding material. So the initial dimming did not cause alarm. But as observations continued, the pattern became clearer. The star was not flickering. It was not pulsing. It was steadily fading. There was no sudden flash of light. No burst of radiation. No powerful explosion marking the end of its life. Instead, the light simply grew weaker over time, as if the star were slowly being hidden from view. Astronomers watched closely. They compared new data with older records. The star had once shone reliably, its position fixed, its brightness consistent. Now, with each new observation, it appeared dimmer. There was no dramatic event to announce what was happening. No bright supernova lighting up the galaxy. No expanding cloud of debris. Just a quiet reduction in light. Behind this fading was the steady force of gravity. Somewhere nearby, unseen and silent, a black hole exerted its influence. The star, which may have orbited safely for a long time, had begun to drift too close. Gravity does not rush, and it does not hesitate. It simply pulls. Slowly, the star's path curved inward. As it moved closer, the gravitational pull grew stronger. The star may have begun to stretch slightly under the difference in gravity between its near side and its far side. But even this would not have produced sound in the vacuum of space. From a great distance, observers on Earth saw only one thing: the light weakening. As the star moved deeper into the black hole's gravitational field, its light had to struggle harder to escape. Gravity bends light. It stretches it. It can drain it of energy. To an outside observer, the star would appear to dim gradually as it approached the boundary beyond which nothing can return. There was no explosion because this was not the typical death of a massive star. It was not running out of fuel in a violent collapse. Instead, it was being drawn inward, step by step. The process was quiet. In space, even dramatic changes happen in silence. There is no sound to carry shock waves. No air to transmit a final cry. Only motion governed by gravity and time. And then, eventually, came the final stage. The star's light became so faint that it was barely detectable. Astronomers continued to watch, measuring carefully, waiting to see if it would brighten again. But it did not. One observation after another confirmed the same result. The star was gone. There was no flash marking its final moment. No signal announcing its crossing of the event horizon. From the outside, it simply faded until it could no longer be seen. The disappearance was not sudden in human terms, but in cosmic terms, it was decisive. A steady light that had once been part of Andromeda's vast spiral was no longer visible. It had crossed into a region where light cannot escape. For those studying the galaxy, this quiet vanishing was powerful in its own way. It reminded them that not all endings in the universe are explosive. Not all change arrives with brightness and force. Sometimes, change is gradual. Sometimes, loss is silent. The universe does not pause when something disappears. The galaxy continues rotating. Other stars continue shining. The slow motion of Andromeda carries on as it always has. Yet the absence is real. A light that once traveled millions of years across space no longer reaches us. The story of that star has entered a new chapter, hidden from view beyond the boundary of a black hole. There is something strangely peaceful in this kind of ending. It is not violent. It is not chaotic. It is simply the steady unfolding of gravity's influence. Space can be calm even in moments of loss. The universe changes quietly. Stars are born in silence, and sometimes they disappear in silence as well. As we reflect on this vanishing star, we understand that even in the vastness of space, events do not always demand attention. Some transformations happen gently, almost unnoticed, except by those who are patiently watching. And far away in the Andromeda galaxy, among billions of remaining stars, the slow rotation continues, steady, balanced, and silent. To understand what happened to the star that vanished, we need to take a closer look at what occurs near a black hole. These regions are unlike anything we experience in everyday life. The rules that guide motion, light, and even time begin to behave in unusual ways under the influence of extremely strong gravity. One of the most fascinating effects near a black hole is the way gravity affects time itself. According to modern physics, the stronger the gravity, the more it slows the passage of time. This does not mean time stops completely, but it moves more slowly compared to areas farther away. Near a black hole, this effect becomes very noticeable. If someone were able to observe a clock moving closer and closer to a black hole, they would see that clock appear to tick more slowly. The closer it gets, the slower it seems to move. From a great distance, it would look as though time near the black hole is stretching out. Light is affected as well. As light tries to escape the powerful pull of gravity, it loses energy. This causes it to stretch into longer and longer wavelengths. To an outside observer, this can make objects appear dimmer and redder over time. The light weakens as it struggles to move away from the gravitational field. This is one of the reasons a star being pulled toward a black hole might appear to slowly fade. Its light is not only being pulled inward, but also stretched and weakened as it attempts to escape. Eventually, the star reaches a point known as the event horizon. This is often described as the edge of no return. It is not a solid surface or a visible line in space. Instead, it is a boundary. Once anything crosses this boundary, it cannot come back. Not even light can escape from inside it. From far away, something approaching the event horizon appears to slow down more and more. Its light becomes fainter and more stretched. It may seem to pause at the edge, fading slowly from view. But this is only how it looks from the outside. In reality, the object continues moving inward, crossing the boundary and entering the black hole. There is no sudden flash when this happens. There is no signal sent outward. The object simply passes beyond the point where its light can reach the rest of the universe. This is why the star in Andromeda did not explode. Explosions happen when energy is suddenly released outward. But in this case, the star was not blowing apart. It was being pulled inward by gravity. Instead of energy bursting into space, everything was moving toward the center. Because of this, there was no dramatic ending. The star's light faded as it approached the boundary, then disappeared once it crossed it. And because space is a vacuum, even if there were intense forces at work, there would still be no sound. Sound needs air or some form of matter to travel through. In the emptiness of space, events unfold in complete silence. Near a black hole, everything becomes very still from an outside point of view. Light grows faint. Motion appears to slow. The surrounding space seems calm and dark. There is no noise, no movement that can be heard, only the quiet bending of gravity shaping what happens next. From a distance, the process looks peaceful. A steady dimming. A gradual fading. Then only darkness where light once existed. This calmness can feel surprising. We often imagine space as full of dramatic explosions and powerful events. But sometimes the most powerful forces in the universe work in the quietest ways. Gravity does not need sound. It does not need to rush. It simply pulls, steadily and patiently. And once something crosses that invisible boundary, it becomes part of a region that cannot be seen from the outside. Hidden in darkness, beyond the reach of light, beyond the reach of time as we understand it. The rest of the galaxy continues moving as it always has. Stars keep shining. Clusters keep drifting. The slow rotation of Andromeda goes on, unchanged. But in one small region, something has passed into stillness. Far from the Andromeda galaxy, on a small planet orbiting an ordinary star, humanity continues to watch. Earth does not feel connected to distant galaxies in everyday life. Our world is filled with its own sounds, movements, and concerns. But high above the surface of our planet, telescopes quietly observe the universe. Some sit on remote mountaintops. Others orbit far above the atmosphere, free from clouds and city lights. Night after night, these instruments collect faint signals from deep space. They measure tiny changes in brightness. They track motion that unfolds over years. They record light that has traveled unimaginable distances. Through these careful observations, humans attempt to understand events happening millions of light-years away. The fading of a star in Andromeda is not something the human eye could notice on its own. It requires patience, precision, and time. Scientists compare images taken months apart, then years apart. They study patterns. They question their results. They test their conclusions. Slowly, a story emerges. A star once visible is no longer there. There is something remarkable about this. From such a great distance, we are able to witness the quiet transformation of a star. We cannot hear it. We cannot touch it. Yet through light and careful measurement, we become aware of its disappearance. This is one of the quiet achievements of humanity. We are small in comparison to galaxies, yet we have learned how to observe them. We have learned how to read the faint messages carried by light. And what we discover is not always dramatic. Not everything in space ends in a brilliant explosion. Not every change lights up the sky. Some events are gentle. Some are gradual. Some simply fade. There is a certain beauty in that. The universe does not need spectacle to move forward. It does not pause for attention. Stars are born in silence within cold clouds of gas. They shine steadily for ages. And sometimes, they disappear just as quietly. Galaxies continue their slow rotation. New stars form. Old stars fade. Black holes sit in darkness, shaping their surroundings without sound. From Earth, we remain observers. We look up at the night sky and see points of light scattered across the darkness. Some belong to our own galaxy. Some come from distant systems like Andromeda. Each one carries a story from the past. The vanishing of a single star does not disturb the balance of the galaxy. The spiral arms continue turning. Gravity continues shaping motion. The universe moves forward as it always has. There is comfort in this larger perspective. Change is constant, but it is rarely chaotic on the grand scale. Even powerful forces like gravity operate with steady consistency. Over immense stretches of time, everything follows the same quiet laws. As we come to the end of this journey, imagine yourself once again beneath a clear night sky. The air is calm. The stars are steady. Above you, the vastness of space stretches in every direction. Somewhere within that darkness, in the Andromeda galaxy, a star has quietly crossed into a black hole. No explosion marked its end. No sound echoed through space. Just a gradual fading, and then silence. Take a slow breath in. Hold it gently for a moment. And breathe out slowly. The universe remains vast and peaceful. Galaxies drift. Stars shine. Gravity shapes the unseen. And here on Earth, we continue to watch, to learn, and to wonder, small observers beneath an endless sky. Allow your breathing to settle into a slow and steady rhythm. The night is calm. The universe is still moving, quietly, above you. As we come to the end of this journey, I want to gently thank you for staying with me all the way to this moment. For the past few hours, we've traveled across space together. We've drifted through a distant galaxy, followed the life of a star, and quietly witnessed its disappearance into the darkness. And through it all, the universe has reminded us of something simple and peaceful, that not everything needs to be loud to be powerful. Some things happen slowly. Some things change quietly. And right now, as you rest, the universe is still moving in that same calm and steady way. Stars are still shining. Galaxies are still turning. Light is still traveling across the vast distance of space. And above you, beyond the sky, that gentle motion continues without sound, without hurry, and without end. If you're listening as you fall asleep, allow your body to fully relax now. Let your breathing become slow and natural. Let your thoughts grow quiet and soft. There is nothing you need to do. Nowhere you need to go. Just rest. As you lie there, remember that the universe is not rushing. It moves with patience. With balance. With calm. And you can rest in that same feeling tonight. Thank you for spending this time here, for allowing this journey to be part of your night. And whenever you need a moment of peace, whenever you want to drift through space again and let your mind slow down, you can always return for another quiet journey among the stars. For now, close your eyes if you haven't already. Take one slow, gentle breath in. And breathe out softly. The night is calm. The universe is still moving slowly above you. Sleep peacefully.